The Rock Whisperer. Do you hear the earth talking to you?
Unit 7-3, Chemical Weathering. So we've talked a little bit about an introduction, we've talked about physical or mechanical weathering, and now we're going to talk about chemical weathering. So chemical weathering is the changing of rocks from one substance to another. And one of the main factors or main things that's involved in chemical weathering is water. And water can do one of several different things. So one, water can dissolve minerals. So when we have rocks are made up of minerals, that water can help to dissolve the minerals. Water can also form acids. How do they form acids? Well, when we add those minerals, it's dissolving the minerals, those minerals get into the water, we can start to form different types of acids. And also, we can form different minerals, and we do that through chemical reactions or through precipitation. Remember the experiment we did, we took two clear liquids, mixed them together, and we wound up with this white, thick precipitate in the beaker. So what we're talking about is hydration. And when we think about hydration, we think about drinking a glass of water. Or when we hydrate and we think that we're an athlete and we're hydrating, we are adding water to our system. One specific example of chemical weathering is oxidation. And what we're doing is adding oxygen. We're adding O2 to a particular substance. And one of the most common known types of oxidation reactions is rust. You can see a picture here of a roof, a metal roof that has rust on it. And why does rust form? Because we're forming a chemical reaction. So the simple version of that is iron plus water gives us iron oxide and hydrogen. If we balance that equation, and some of you will be seeing this next year in chemistry, we have 3 iron plus 4 water gives us iron oxide and 4 hydrogen atoms. Carbonation. Most of us probably think carbonation, thinking of the diet soda down here in the right-hand corner. What actually is carbonation, and how does carbonic acid form? We take carbon dioxide in water, and that's what we have in our soda, is we have carbonated water. You are forming H2CO3, which is the carbonic acid. So when we define carbonation, we're talking about the dissolved carbon dioxide that's in the water. That's producing the fizz or the bubbles in that particular case. So what can carbonic acid do to rocks? Well, it can dissolve minerals. Think about the picture with the teeth and the dental problems that people had because of the carbonic acid from the excessive amounts of soda that people drank. And right here we have a more molecular diagram of what's happening with carbonic acid. We have water, we have our carbon dioxide, and we're forming our carbonic acid here. Next one is sulfuric acid. And we probably most often hear sulfuric acid when we're talking about acid rain. So where does the sulfur come from? It comes from pollution. We have many different types of pollutions that we can have. Sulfur oxide, nitrous oxide type compounds, and a lot of other things that can be put into the air. When we think of acid rain and think of things being an acid, we initially think of a pH less than 7. But when you look up, and I went out and looked at the EPA website, and they talked about acid rain as being typically less than 4.3. Average rain that's not acidic is actually about 5 to 6, just based on the normal compounds that are in our atmosphere. Why is acid rain bad? Well, because those lower pHs have a dramatic effect, or can have a dramatic effect, on plants and animals. Especially fish. Some fish live in a very narrow pH range, and changing the pH even by like a half a number can have some pretty devastating effects. This is showing you what sulfuric acid would look like, H2SO4. And the last type of chemical activity we're going to talk about is plant acids. And we talked about this a little bit earlier with the mechanical or the root pry. So what's happening is there are acids in the roots of plants, and those acids help to break down the rock, as we have previously said. That allows the roots to take hold. But one really good example that you can see a lot in our area is with moss or lichen. And what happens is sometimes you peel back moss off of a rock, and what do you find underneath? It's almost like a sand or little teeny pieces of rock that are underneath. So in this particular picture here, you can see there's a lot of moss, and this in the back, that kind of green stuff is a type of lichen that you may find on rocks also.
Don't forget to listen to the earth. You just may hear it speak.